Example 7, let's evaluate the integral x dx over the square root of 3 minus 2x minus x squared, like so. So we are looking at this solution. I'm looking at the denominator. Let's say, wait a second. This doesn't look like x squared minus a squared, or a squared minus x squared, or x squared plus a squared, right? This is a trinomial. It's not a binomial, and it's not the sum or difference of squares. So what we're going to do here to allow trig substitution? Well, in this technique, in this case, actually, we're going to employ a fairly forgotten technique called completing the square. Remember something like that? Some of you may have learned it. We used to teach it in intermediate algebra. Now we teach it in college algebra. We also repeat it in pre-calculus courses. Some of us do. So we'll complete the square of the trinomial in the denominator. So complete the square in the denominator. So how are we going to accomplish that? Well, I want to have something squared here, something plus or minus something squared. So we're going to do the following. When I look at 3 minus 2x minus x squared, I'm going to add to the 3 minus x squared plus 2x. Okay? And I'm saying that I like to add something to x squared plus x such that this trinomial will be a square. So what do I need to add here? 1. Because x squared plus 2x plus 1 is x plus 1 squared, right? But am I adding 1 or really subtracting 1? I'm subtracting 1 because I have the negative in front. So to compensate it, I need to add 1, like so. Okay, so now I end up having 3 plus 1, or 4, minus, instead of x squared plus 2x plus 1, I have x plus 1 squared. So what do you think will be my substitution?
2 squared minus u equals x squared.
I want to have 4 minus u squared, so u will be x plus 1. So we let u equal x plus 1. Of course, we need du, so du equals dx, but we also need x because we have x in the numerator, so x will be u minus 1. Okay? This is an indefinite integral, so we don't need to worry about boundaries and such. So our original integral going to look like now with the u as the integral. Instead of x, I have u minus 1. Instead of dx, I have the u. And here, I have the square root of 4 minus u squared. The next substitution will be u equals 2 sine theta. And again, continue du equals 2 cosine theta d theta. And as far as the the denominator is concerned, we're going to have the square root of 4 minus, 4 minus u squared will be the square root of 4 minus 4 sine squared theta. And factor out the 4, take its square root, so you have 2 square root of 1 minus sine squared. And of course, this will be the cosine squared. So the square root of the cosine squared is the cosine. So the denominator now look like 2 cosine theta. So let's see what is the, once again, we are blessed by not having boundaries to worry about. And now the integral is going to look like the following. We have u minus 1. Well, that will be 2 sine theta minus 1. And du is 2 cosine theta, d theta. And here we have 2 cosine theta. So that's kind of nice, because everything disappeared. So we end up having the integral of 2 sine theta minus 1 d theta. And this is easy integral to, this is easy to integrate. So we end up having negative 2 cosine theta minus theta plus c. Okay? And now we need to go ahead and express everything in terms of x. So in this case, the flip side of not having definite integral is that we do need to work the path backward, so we end up having x at the end of the day. So let's see how this works out. Well, the u is 2 sine theta, so let's see how we get cosine theta. We know that, first of all, since u equals 2 sine theta, then sine theta equals u over 2, and theta equals the inverse sine of u over 2. Okay? And of course, u is x plus 1, so we're going to say that theta equals the inverse sine of x plus 1 over 2, like so. Okay, what about the 2 cosine theta? Well, let's see. Negative 2 cosine theta will be negative 2 times the square root of 1 minus sine squared theta. Notice that I don't use the triangle here. I could have used the triangle, right? The right triangle, but here, just to go from the sine to from the cosine to the sine is not that hard. And the sine, of course, is sine theta is u over 2, so we end up having negative 2, the square root of 1 minus u over 2 squared, like so. Continue to work, you have negative 2, this will be 4, so it will be the square root of 4 minus u squared over 4, and since the square root of 4 is 2, you end up having negative the square root of 4 minus u squared. And 4 minus u squared, if you remember, is what we started with, right? 4 minus u squared is 3 minus 2x minus x squared. So it will be negative the square root of 3 minus 2x minus x squared. And if you don't remember to do so, well, if you plug in, if you substitute u with x plus 1 and square it, you end up having what you started with. But since I know that that's how, when we completed the square, that's what we obtained, then I just walk the path backwards. So the solution, so I will be from negative 2 cosine theta, we obtain negative the square root of 3 minus 2x minus x squared, right? And from negative theta, we get minus the inverse sine of x plus 1 over 2, and c is at the end of